Hey guys, let's do it. Page 9. It says, prove theorems about lines, angles, use theorem about lines and angles to solve problems. These theorems might include vertical angles are congruent when a transversal crosses parallel lines, alternate interior angles are congruent, corresponding angles are congruent. Points on a perpendicular bisector of a line segment are exactly equidistant to those segments and endpoints. Okay, so we went over a lot of this stuff early on in the school year, and these are only 4 questions, so we should be pretty good on this. Let's take a look. Question 1 said, which statement should be used to prove that the measure of angles 4 and 6 sum to 180? So let's list all of these on my formula sheet. So I'm going to go back to my formula sheet. I keep going to this formula sheet, right? And so it's AASC. The parallel line theorems are AASC. Alternate interior angle theorem, alternate exterior angle theorem, same side interior angle theorem, same side exterior angle theorem, and corresponding angle postulate. So, boop, boop, bink, boop, boop, bink, boop, boop, bink. What are these angle relationships? Well, alternate interior would be that, right? They're interior and they're one's on the left, one's on the right. Alternate exterior would be this, one's on the left, one's on the right, and both of them are outside. So you remember this, if you're inside that flap, right? You're inside those 2 parallel lines. If you're outside, then you're outside these parallel lines. So that's exterior. All right. So let's see. Same side interior. That would be this small one and this big one. Those are same side supplementary, meaning they add up to 180. They can't be equal because one's fat and one's skinny, right? Same side exterior. So let's put these both on the right. There's a skinny one and a fat one. They can't be equal. Same side supplementary again. An angle, I'll call this angle 3, and angle 4 are once again supplementary. So what are corresponding angles? Those are congruent. So the rest of these, and that starts with the letter C, so the rest of these are congruent, meaning equal to one another. So the theorem goes, if the lines are parallel, then these 5 theorems apply, okay? Okay, so let's see what we have here. Let's call this angle, we already had angle 3 and 4, so I guess I'll call this angle 5 and angle 6. Angle 5 has to be congruent to angle 6. Let's call that 7 and 8. Angle 7 has to be congruent to angle 8. And what is corresponding angles? Well, those are, I call them slider lines. One's in the road and one's out of the road, and they're equal. So I'm going to call this 9, I guess. 9, angle 9, angle 10. So angle 9 is congruent to angle 10 because they're corresponding. They're both on the same side. One's in the road, one's out of the road. These are the theorems that I jotted on my formula sheet. Now let's go back and use them in my question for my learning goal on page 9. All right. Why would angle 4 and 6? Oops, so they're on the same side and they're inside the road. So I'm looking for same side interior angle theorem. However, I don't see that from any of those. So they're asking that you prove it using a combination. Okay, so let's try each one. What would angle 2 and angle 4 be congruent because of vertical? Well, yes, angle 2 and angle 4 are congruent. Then would angle 5 and 6 form a linear pair? Yes. Okay, but then how do I get from 4 to 6? I don't think that's enough. The next one says angle 4 and 7 are congruent. Yes, because they're corresponding. So this is true. So we could say angle 4 is congruent to angle 7 because they're corresponding. So that we could say that. And then angle 6 and 7 form a linear pair. That's true. So angle 6 plus angle 7 equal 180 because that's a linear pair. And so then notice how we can substitute angle 4 for angle 7. So instead of writing angle 7 here, we could write angle 4, and we'd say using substitution, I am able to come to the conclusion that I'm adding those. All right, that's what we tried to prove. So let's still read C because got to make sure. Angle 3 and 4 are congruent. 3 and 1 are congruent because they're vertical. I agree. And angle 2 and 4 are vertical. Yeah, but that doesn't help me prove 4 is congruent to 6. Or not congruent, but that they add up to 180. So angle D, they said angle 5 and 8 are a linear pair. Okay. Angle 6 and 7 are a linear pair. That's great. Those are true, but that doesn't help you prove that these across. So definitely we like B. Corresponding angle postulate and linear pair can be used to prove the same side interior angle theorem. Question number 2. For what value of x is f and g parallel? So this would be the converse, right? So back on my cheat sheet, I can say if the lines are parallel, then this is true. And this is true. And this is true. And this is true. And this is true. But I could also do the converse where if in reverse order they told me 9 and 10 are equal to each other or congruent, then I know these lines are parallel. That would be the converse theorem. So I'm going to jot that down here. The converse theorems, so it could be any of those 5, say if angles, depending on the theorem, are congruent, or if they say the angles are supplementary, then you can come to the conclusion that the lines are parallel. Okay. So back to my page, right? Question number 2. I'm looking for a converse, and I need to find which are these angle relationships. So if this is my road, right, this is my interior stuff, these angles are on opposite sides, and they're out of the parallel line. So they're alternate, they're exterior, and that's alternate exterior angle theorem. So alternate exterior angle theorem, and it's converse. Yay! Now, they don't ask, but we could solve for x just for extra practice. So if they are equal, oh, wait, I fell into a trap. It could be B or C, so I do have to solve for x. Okay. Because if it's 8, I need B, and if it's 7, I need C. Okay, so let's set these equal to each other. And then if I subtract 10, I get 2x. Copy the rest down. If I add 9, I get 14. If I divide 2 on both sides, I get 7. Beautiful. Okay, so it can't be B either because it's not 8, it's 7. Could I plug this back in if I really wanted to? Yes. So any high stakes test, you might also want to plug it back in just to be sure. And you get 75. Here you plug it back in. You get 84 take away 9, which is 75. What do you know? Definitely right. Question 3. If angle 1 and 2 are congruent, can you conclude that any of these lines are parallel? So if 1 and 2 are congruent, then that locks in this angle, and it locks in that angle. Okay? So if we'd extend these lines formed by this angle, this helps us see the lines we need to see. If those lines are forced to be equal, then it forces these two lines to be parallel, using the converse corresponding angle postulate. Okay, so let's see if our answer is here. Could you conclude these lines are parallel? I'm looking for a yes, because N and P would be parallel because the corresponding angles are congruent. Yes, I like it. I like it. This is the answer we want. Question number 4, last one on the page. Peach Street and Cherry Street are parallel. Okay, so we have our regular theorems, our double A, double SC are in play here. If they're parallel, Apple Street intersects them shown below. If we are given the measurement of this one, so this is acute, right? And we're given the measurement of this one, this is obtuse, then what is angle 2? So they'd like me to solve for angle 2. All right, now if the only number greater than 90, if the diagram is not really distorted, then it definitely should be 2, but we don't know that for sure. They could really make a distorted picture. Okay, so I'm not setting them equal to each other. I have to set them to add up to 180. So how can I do that though? Because I don't see an angle relationship. Well, notice, I'll just call this angle 3. Notice that before I go down that path, angle 1 is congruent to angle 3 because of vertical angles. Right? They're right across each other and they meet at a single point, right across there. And then notice angle 3 plus angle 2 has to add up to 180 because these guys are on the same side and they're interior angles. So same side interior angle theorem. And now I can substitute angle 1 where I see angle 3. So see how I know that angle 1 and 2 should be supplementary. I just use substitution. Okay, now with this information, I'm going to use substitution again to plug this in. So angle 1 is 2x plus 36. And angle 2 is 7x minus 9. And 2x and 7x and 36. And all right, let's combine like terms. We get 27. And we're going to divide by 9. And we get 17. But we're not done because they've asked us for angle 2. So angle 2, if we substitute 17 in for x, so the measure of angle 2 is, I'm just copying this down again, 17 times 7 minus 9. 17 times 7 minus 9. Is 110. Oh, and looky there. My guess in the beginning was correct to begin with. Nice work.